Hello my dear children, welcome back to the lecture series of Grade 12 Maharashtra Board Chemistry. Name of the topic is alcohol, phenols and ethers. This is the fourth video of the same topic where we are going to start with phenols today. In the previous three videos we have completed everything about alcohols. Today we are going to start with phenols. My name is 𝐒𝐿𝐵𝗲𝗍 and you are watching 𝐒𝐿𝐵𝗲𝗍 classes. Let's get started. So phenols are, in the phenols, a hydroxyl group is bonded to aromatic ring. Hydroxyl group is bonded to aromatic ring means what? This is my benzene ring or aromatic ring and OH group is bonded to this. This compound is called as phenol, or the other name of phenol is carbolic acid. Okay, so this is called as phenol or carbolic acid. Now let's come to the nomenclature. We always do the trivial name or the common name and the IUPAC name. So the first compound which I showed you, this is phenol. The other name is phenol, or it is also called as benzene ol, because it is benzene and ol is attached to benzene. So it is benzene. The E will not be there at last because we will start with ol. So it is benzene ol. But it's more famous with phenol, the name phenol, so we will call it as phenol. Next one is phenol, and then there is a CH3 group attached to it. So we know that whenever CH3 group is attached to the benzene ring, this compound is called as toluene. Okay, so this is toluene. So the parent molecule here, it will be toluene, and there is a OH group attached to the second position. Okay. So the common name of that is orthocresol, which we need to remember. When OH and CH3 group are adjacent to the benzene ring, the common name of the compound is orthocresol, and the IUPAC name is 2-hydroxy. This is my first carbon and this is my second carbon. So it is 2-hydroxytoluene. Okay. Next compound is OH and NO2 is attached to the meta position. Phenol and then NO2 is attached to the meta position. This is called as meta-nitrophenol. Okay, the meta is attached to the, nitro is attached to the meta position, so it is meta-nitrophenol. And the IUPAC name is 3-nitro. In IUPAC we don't call ortho meta para, we call it 1, 2, 3. So it is 3-nitrophenol. Fourth compound is both OH groups are attached adjacent to each other in the benzene ring. The common name of that is catechol. Okay, OH groups are attached to adjacent to each other in the benzene ring. Common name is catechol, and the IUPAC name is benzene 1,2-diol. Okay, it is benzene and then 1,2-diol. It looks like this. This is my benzene ring and there are two OH groups. So it is 1, 2, 1 position and 2 positions. So it is 1,2-diol. Okay. Next is OH and OH. They are attached to meta to each other. The positions is meta now. This is, the common name is resorcinol, and this is benzene 1,3-diol. Now this is my first, second and third carbon, so it is 1,3-diol. Next is they are para to each other, so this is called as quinol, and the IUPAC name is benzene 1,4-diol. Now OH group are in the first position, second, then in the third position, fourth, and then in the fifth position. So it is called as fluoroglucinol. The common name is fluoroglucinol. But the IUPAC name is benzene 1,3,5-triol. Okay. Come to the next one. This is my first, second, third, fourth, fifth and sixth. Okay, sorry. This is not first. We will call, okay, 1 minute. Here the OH groups are one after another. So I call this as 1, this as 2 and this as 3, then 4, 5 and 6. 1, 2, 3 positions the OH groups are. This is called as pyrogalol, the common name, and the IUPAC name is benzene 1,2,3-triol. Now we start with the preparation part of phenol. So the first preparation is from chlorobenzene and the method is called as Dow's process. It is called as Dow process. So here we are taking chlorobenzene and we are treating chlorobenzene with NaOH, sodium hydroxide. So what happens is HCl comes out from here and the rest of the part it gets attached to the benzene ring. So we get sodium phenoxide ion. So this is ONA and plus HCl comes out. Okay. So this is my chlorobenzene. This is chlorobenzene, and here I get sodium phenoxide. This is called as sodium phenoxide. Now in the next step, this is a two-step process. Actually in the next step, the sodium phenoxide is diluted with acid. So this is sodium phenoxide, which is diluted with HCl. What happens here is NaCl comes out from here. This is your NaCl coming out, and we get our phenol. So it is OH attached to the benzene ring, which is our phenol, and the byproduct is, of course, it is NaCl. Okay, so this is the first method, preparation of phenol from chlorobenzene, which is also called as Dow's process. Second method is a commercial method of preparation of phenol, which is done from isopropyl benzene. This compound is called as isopropyl benzene. The other name of this compound is cumene. This is also known as cumene. This is a common name. Cumene or isopropyl benzene is oxidized in presence of air. So in presence of air, it will be reacting with oxygen in presence of cobalt naphthalate. Cobalt naphthalate is the catalyst over here. Cobalt naphthalate at 423 Kelvin temperature, and we get a compound like this. See, this CH3 is as it is, and this CH3 is also as it is. Here we have CH. You can see this is the hydrogen over here. You just have to insert two oxygen atom in between the carbon and hydrogen. So we have a peroxide linkage over here. Okay, so we get a peroxide linkage, and then we treat this reaction with treat this compound with hydrochloric acid. That means we are acidifying it with hydrochloric acid with little bit of heat. We get phenol, and another byproduct is CH3COCH3. How it is coming? Just check it over here. This is your CH3COCH3, that is your acetone, and this OH gets attached to the benzene ring, which is your phenol. So we get our main product, that is phenol, and the byproduct is acetone. So this is the commercial method of preparation of phenol from cumene or isopropyl alcohol. Come to the next one. The next preparation is from benzene sulfonic acid. So this is my benzene sulfonic acid. SO3H group is called as sulfonic acid group, which is attached to the benzene ring, and it is treated with NaOH, sodium hydroxide. So this is acid, you know, this is acid, and this is base. So obviously acid and base will give you neutralization reaction. So here we get H2O comes out from here as water, and Na gets attached with SO3. So we get this way SO3Na plus H2O. This is called as sodium benzene sulfonate salt. Sodium benzene sulfonate salt. So in the first step we get sodium benzene sulfonate. It is just a neutralization reaction. Then we take this sodium benzene sulfonate with NaOH again. Okay, so what happens here is you just consider two. What happens here is Na2SO3 will come out like this. This is your Na2SO3. This comes out as a byproduct, and OH gets attached over here. So we get phenol, OH is attached over here, and the byproduct is Na2SO3. Na2SO3. So the first step we are getting sodium benzene sulfonate. Now this sodium benzene sulfonate we are taking in the second step, and we are treating that with NaOH. So consider here 2 moles of NaOH. So what happens is 1 mole of NaOH will come out as Na2SO3 like this. Na2SO3. 1 mole of water will come out, and this ONA, I will just show you like this. 1 minute. This is NaOH. This is another mole of NaOH. So 1 mole of Na2SO3 is coming out, 1 mole of water is coming out, and ONA gets attached to the benzene ring. So we get ONA attached to the benzene ring, that is sodium phenoxide, and the byproducts here are Na2SO3 is one byproduct and the other one is 1 molecule of water. So basically here we are using 2 molecules of NaOH. Okay. So if I write it in a proper manner, it will be like this. This is my benzene, sodium benzene sulfonate, SO3Na, and this is treated with 2 molecules of NaOH. So we get sodium phenoxide salt, Na2SO3 and H2 as a byproduct. Now in the next step, we have to acidify this sodium phenoxide. This is my sodium phenoxide which I need to acidify. Which I need to acidify with HCl. So NaCl comes out and we get our phenol. So this is my phenol and NaCl comes out. This is your phenol. Fourth and last preparation of phenol, we are using aniline. This is aniline. Okay. This reaction is also called as diazotization reaction because the first step is diazotization, where we form a diazonium salt. So aniline is treated with HNO2. HNO2 is called as nitrous acid. How do we get nitrous acid? By mixing sodium nitrite and HCl. If you mix sodium nitrite and HCl, HNO2 is formed and NaCl comes out. So this is how we are getting HNO2. So we are preparing HNO2 in situ with the help of sodium nitrite and HCl. The temperature is kept 273 Kelvin temperature. We get benzene diazonium chloride. So we get N2Cl here, that is benzene diazonium chloride, and 2 molecules of water comes out. This is benzene diazonium chloride. Since here there is a diazonium salt form, therefore this particular step is called as diazotization reaction. Okay, so you can see this N and this N, N2 and this Cl, N2Cl is attached to the benzene ring. Rest of the atoms are hydrogen, oxygen, so that is giving you 2 molecules of water. Now in the next step, benzene diazonium chloride is hydrolyzed or it is reacted with water. So what happens is, this HCl comes out from here, HCl comes out, nitrogen also comes out at nitrogen gas, and OH gets attached to the benzene ring. So we get our phenol here, this is phenol, and nitrogen comes out and HCl comes out. Since we are getting 2 gases over here, the second step is very spontaneous. So you just add water to benzene diazonium chloride, we get our product, that is phenol. Okay, so these are the 4 preparations of phenol. Now we proceed towards the physical properties of phenol. Already I told you that phenols are called as carbolic acids. Okay, physical properties of phenol, the first thing is nature of intermolecular forces. Now the physical properties of phenols and alcohols are exactly same. So whatever you have studied in alcohol, you can study the same for phenol also. Phenols are polar molecules because of the presence of OH group, and because of that they are held together by the intermolecular hydrogen bonding. So you can see this is one phenol molecule, okay, and this is another phenol molecule, and they are held together by the intermolecular hydrogen bonding. Second physical property is physical state. So phenols are colorless, toxic, low melting solid having characteristic phenolic or carbolic odor. This odor, what they possess, is called as phenolic odor or carbolic odor. It is a peculiar kind of odor which gives you the confirmation of the phenolic, phenols. Okay. Come to the next point, boiling points. We all know that boiling points increases with the increasing molar mass. Here also we will see the boiling point increases with the increasing molecular mass. Next one is solubility. So phenols show appreciable solubility in water due to the ability to form hydrogen bonding. They form hydrogen bonding with water, and because of that they are little soluble in water. I'll show you how they form hydrogen bonding with water. So this is my phenol. This is my phenol, and this is my water molecule. This is one of the water molecule. This is another water molecule. How do I write it? So this is this side. I write O, this side H, this side H. So we see the hydrogen bonding forms like this. This is how the hydrogen bonding is forming between water and phenol. Because of that, phenols are little soluble in water. Okay, so we have completed the phenol, the introduction part of the phenol, the nomenclature, the preparation and the physical properties today. In the next video, I will come up with the chemical properties of phenol, and then we'll start with the last compound of this chapter, that is ether. So if you are finding these videos are beneficial to you, please subscribe the channel and press the like button. Thank you so much. Stay tuned for the next video.